This is a brief summary of the Open Ampule Pesticide CRM Stability Study. The two products selected for the study are our two multi-residue pesticide kits designed for both GC and LC workflow use. Pictured here are those two products which actually contain a total of 19 individual CRM ampules. Note each ampule is listed by product number and indicates which group of pesticides are contained in each ampule. This was done to separate or segregate certain pesticides from each other to reduce their likelihood of degradation during storage. Our study was designed to show how long the contents of each ampule would remain stable after opening the ampules and storing prior to and in between use. Study design is described here. New LC and GC kits were taken from inventory. One kit was opened at the beginning of the study, and the contents of the ampules were transferred to autosampler vials and analyzed in triplicate immediately. The remainder of the contents were transferred to deactivated storage vials that are provided or included with the product and stored in both refrigerator and freezer conditions. Since new LC and GC kits were opened at each time noted and analyzed in triplicate throughout the study, we consumed 5 LC and GC kits for our study. So you can see here at time 8 hours, we cracked open a new set of ampules, brand new set of ampules, removed the other stored vials from the refrigerator and freezer. We transferred small portions of the fresh materials to autosampler vials and analyzed those. And we tested them again, reanalyzed the stored refrigerator and freezer vials on the same instrument with triplicate injections at the same time. We then repeated the above steps at time intervals of 3 days, 7 days, and finally at 31 days. Here's a graphical representation of the study, just to give you an idea in summary of what the study looked like. Again, on the first day, we cracked open fresh ampules, the 19 ampules. We transferred a small aliquot to autosampler vials and immediately analyzed those. Then we transfer the remainder of the contents using the deactivated storage vials that come with the kit. And we highly recommend our customers use these vials because they're specially designed for maintaining stability of the mixes. We then store these vials in refrigerator and freezer conditions and kept them there until the next cycle. So then you can see at 8 hours, 72 hours, 7 days, 31 days, we cracked open brand new kits, all fresh ampules, analyzed them against the stored vials. So this is the study design. Analysis results were charted for each of the pesticide compounds using the average peak areas of the triplicate injections, as shown in the example on this slide. Error bars at 5 and 10% variance from the initial peak areas were calculated. A 10% variance was used to determine whether a compound passed or failed to remain stable during the specified time frame after opening. These results are what determined whether a compound passed or failed during our experiment. This table shows the results of the study for the GC multi-residue kit. Note here listed down this column are the ampule numbers 1 through 9, catalog numbers. And then across the top, we see at the 8 hour, 3 day, 7 day, and 31 day time intervals when we cracked open fresh ampules and reanalyzed the stored vials. Both at freezer and refrigerator conditions, we see all these green P's. Now the green P's represent the mixes that passed with less than 10% variance. And if there are any red F's, you'll see that the failures are anything that was outside of the plus or minus 10%. So for the GC kit, we saw very good results for the entire 31 days of the study. All 9 ampules met this criteria. For the LC kit, we saw almost the same results. Again, ampules listed here, catalog numbers, same intervals, refrigerator and freezer storage conditions for each interval. We see mostly green peas, so the majority of the mixes passed. However, we did observe 4 failures. We'll take a closer look at these 4 failures now. In the ampule number 2, which is a carbamate urine compound mixture, we see that benfiracarb failed with a percent difference mean of 11.5% at day 31, but only in the freezer stored ampule. We also see that isoprocarb failed at the 7-day mark in both stored vials, the one stored in the freezer and the refrigerator, but just outside of our limits, 12.1 and 10.2%. And that was in another carbamate urine mixture. And then the fourth compound or failure was ampule number 5, organonitrogen compounds. We saw Symetrin fail with a 19.2% difference. Now, this was the highest failure out of all 4. It failed on the low side at the 7-day mark, only in the freezer mix, though. The refrigerator mix remained stable, and thiabendazole also failed, but just squeaking outside of that 10% error bar on the low side at the 7-day mark, also in that same freezer stored vial. So conclusions we can draw from this study are that vast majority of the pesticide mixes in the 2 multi-residue kits remain stable for the entire 31 days of the study period after opening the ampules and properly storing them for reuse. 3 of the 4 failures with the LC kit were minimal and occurred at the 7-day test cycle. These same mixes passed for the remainder of the study period. And refrigerator storage after opening showed slightly better stability for the LC kit, since 3 of the 4 failures occurred in the freezer stored mixes.